to lesson 2 of Fundamentals of Machine Learning. In this lesson, we'll explore the exciting world of machine learning, a powerful subset of artificial intelligence that has rapidly transformed industries, from healthcare to finance and even entertainment. If you wondered how algorithms can learn from data and get better over time without explicitly being programmed, this is the lesson for you. By the end of it, you'll have a solid understanding of how machine learning works and why it's becoming a game changer in many fields. What is machine learning? Machine learning is all about teaching computers to learn from data and improve over time, just like humans do. Instead of telling the system exactly what to do for every single situation, we create algorithms that allow the system to learn from past experiences, like the data, and make smart decisions in the future. It's like giving the machine the ability to learn from trial and error, or in more technical terms, from patterns and relationships hidden in the data. These algorithms identify patterns, make decisions based on that data, and improve their own process through experience. Over time, the machine becomes smarter and more accurate just by interacting with data and adjusting its behavior based on feedback. Machine learning can be broken down into three main parts, each with its own approach to learning from data. The first one, supervised learning. This is the most common type of machine learning. In supervised learning, the algorithm is trained using labeled data, data that already has the correct answer attached. Think of it like a teacher showing a student the answers to a math problem and then letting them practice by solving similar problems on their own. Supervised learning is widely used for classification rank tasks. The system predicts a category or class based on input data, like an email or spam, or regression tasks. The system predicts a continuous value, like predicting the price of a house based on features like location and size. An example is, imagine you have a data set of emails and are labeled as either spam or not spam. The algorithm will learn from these labeled emails and then be able to classify new unseen emails as either spam or not spam based on the track patterns it's learned. Next, we have unsupervised learning. Unlike supervised learning, unsupervised learning works with unlabeled data. The algorithm doesn't know what the correct answer is. It has to figure out on its own by detecting patterns or relationships in the data. Unsupervised learning is useful for clustering. That is, grouping similar data points together, like grouping customers based on their shopping habits, or association. Identifying relationships between variables, like people who buy bread also tend to buy butter. So an example is, let's say you're analyzing customer behavior on an online shopping site. An unsupervised learning algorithm might find that people who buy a certain brand of shoes are also likely to buy a specific type of jacket, even if you didn't tell that these items are related. The system discovers these patterns by itself. Finally, we have reinforced learning. In reinforced learning, the algorithm learns by interacting with its environment. It takes actions, receives feedback, and uses that feedback to improve. Think of it like playing a video game. You make decisions and get points or penalties based on your actions, and with each play, you improve your strategy. Reinforcement learning is perfect for tasks like robotics, teaching robots to navigate a room or perform a task. Game playing, AI systems that can play and master games like chess, Go, or even video games. Autonomous vehicles, self driving cars that learn how to navigate traffic and make decisions on the road. An example is a self driving car uses reinforcement learning to receive feedback after each action it takes. If it avoids an accident, it gets a reward, but if it crashes, it gets a penalty. Over time, this car will learn to make safer decisions based on the feedback. Key algorithms in machine learning. Now that we've covered the basics of machine learning, let's talk about the key algorithms that help make these learning processes possible. These algorithms are the building blocks of ML models. Linear regression. Linear regression is a simple algorithm used for predicting a continuous output based on one or more input variables. It works by finding the best fit line that minimizes the error between predicted and actual values. Imagine you're predicting the price of a house based on its size. So an example is, linear regression will try to draw a straight line through the data points, house size versus price, that best represents the relationship between the two. Decision trees. Decision trees are a popular choice for both classification and regression tasks. A decision tree splits the data into branches based on certain decisions or features. At each step, the algorithm chooses a feature that best divides the data, like a flowchart of decisions. An example is, if you were trying to decide which restaurant to eat at, a decision tree might start with the question, do you want Italian food? If the answer is yes, the tree branches out to suggest different Italian restaurants. If no, it branches out to other cuisines. So KNN, or K nearest neighbors, is a simple but effective instance-based learning algorithm. It classifies new data points based on the majority class of the k nearest data points in the feature space. In other words, it looks at the closest data points to make this decision. So an example is, imagine you want to classify a new animal as cat or dog. KNN will look at the closest examples in its data set, or so that's other animals data set, and decide the label based on the majority. If three or of the nearest neighbors are cats, the new animal is classified as cat. So to evaluate model performance, once a machine model has made predictions, we need to evaluate how well it's doing. Here are some of the most common metrics used to assess the performance of a model. So first we have accuracy, which is the percentage of correct predictions made by the model out of all the predictions. It's most useful when the data is balanced. So if there's a similar number of each class. Precision is when it measures how many of the predicted positive results were actually correct. It's particularly important when false positives have high costs, like diagnosing a disease when the person doesn't actually have it. Recall. So recall measures how many positive results were correctly predicted. It's crucial when false negatives are costly, like failing to detect a disease when the person hasn't. The F1 score is a balanced metric that combines both precision and recall. It's a good choice when you need to balance the two, especially when the dataset isn't perfectly balanced. MSE, or mean squared error is commonly used for regression tasks. It calculates the average of the squared differences between predicted and actual values, giving an idea of how far off the predictions are. So in this lesson, we've covered the basics of ML, machine learning, including its definition, key types, algorithms, and performance metrics. These foundational concepts set the stage for more advanced exploration of AI. Machine learning is a powerful tool with endless application, from predicting customer behavior to driving autonomous cars. Now that you have a solid grasp of the basics, you're ready to dive deeper into the world of AI.